Hello student, in today's lecture we are going to discuss one of the important topics of physical chemistry. The topic name is thermodynamics. Okay, so you see there are two words in topic name. First one is thermo. The word thermo related to temperature and the word dynamics related to motion or power. So basically in thermodynamics we use temperature to keep any system in motion or power, that is thermodynamics. So in today's lecture we are just discussing some basic parts of thermodynamics, that is what is system, what is surrounding, what is boundary. There are some terms which are commonly used in that chapter. First one is system. So what is system? Part of universe, part of universe under observation, so basically system is part of universe under observation. Surrounding is part other than system. Part other than system. All the other part other than system is called surrounding. Okay. And one more important part, that is boundary. So the part which separates system and surrounding is called boundary. So if we observe part of universe under observation, see if you observe that container which are filled with liquid, so if we are observing the changes in that part, so it is part for us is a system. The part other than that system is our surrounding, and the part which separates system and surrounding, that is our boundary. Now the question comes in your mind is that boundary is real or imaginary. So in that example you can see that the wall of container we are clearly seeing, but in that case we can't see any difference between system and surrounding. So this is our imaginary boundary. And this boundary is real. So there are two type of boundary. One is real boundary which we can see, and other boundary is imaginary. So in universe there are lot of system. If you observe any river, any pond, so this is the part of system. Any part which we are observing. So if you are observing that lecture, this is also a system for you, and other things other than that lecture or that board, that is what surrounding for you. And the part which separates system and surrounding, that is called as boundary. So boundary may be real or imaginary depending on the system you have to be given. Okay, so let's discuss what is system. So there are three type of system. We will discuss one by one. One system is open system. Second system is closed system. And third system is isolated. So one by one we will discuss. Open system is those in which exchange both matter and energy, exchange both matter and energy with surrounding, those part is called open system. In closed system, only exchange of energy, not matter, is called closed system. And in isolated system, no exchange of matter and energy, no exchange of matter and energy between system and surrounding, So these are the three type of system. One is open system, second one is closed system, and third one is isolated system. So let's see the example. What is open system? See, if we taken any open container in which we fill some hot liquid, okay, hot liquid. So when we keep that container in any open space, what we observe is, as it is a hot liquid compared to the surrounding, there is some matter in the form of steam directly exchange with surrounding, and in other, from that wall, energy is also exchanged from that wall. So this is a open system example. In second case, if we take same hot liquid, but this time our vessel is closed, so this is also hot solution, but this time, as it is a vessel closed, so only energy can exchange, no matter not exchange, as it is a closed, so directly steam cannot pass from that container. Okay, the third system, in which one is closed container and above that we have insulated surface. So what that insulated surface does is, it cannot exchange energy, as it is insulated. The heat comes out from that, but because it is an insulated surface, no heat exchange between system and surrounding, so no energy exchange. And as it is a closed vessel, matter is also not exchanged. So this is type of isolated system. We can take example in day-to-day life is thermos flask. It is also isolated system, but it is not 100% isolated system, because we observe that in thermos flask there is also after some hours, there will be whatever the liquid we have put in that one. If you put tea in that one, it is hot for some times, but after that it will be cold. After some time it will exchange its energy with surrounding. So there is no 100% isolated system actually. So thermos flask is just like example. In closed system, we can take the example of refrigerator. In refrigerator, as it is closed, so no exactly matter transfer, but energy is transfer. It can transfer its heats to surrounding. And in open system, any open container, we can take an example. So that already we see there are lot of examples, means in our household things, just like in kitchen, if we keep the water on the gas, and if water is heated and there is no we are not using closed vessel, we are just using open vessel, so that time we can see that steam is comes out from that vessel, and also energy from its wall is also exchanges. So these are the common example, nothing different in that one. Okay, so these are the three types of system. Okay, so in next part we'll discuss what is the extensive and intensive property. One is extensive property, one is extensive property, and one part is intensive properties. Okay. Intensive properties. So what is extensive property? Basically those property which exchange, which depends on quantity of matter, which depends on quantity of matter present in the system, So we can take example of that, that is mass, volume, internal energy, all forms of energy we can take in example, internal energy. Okay. So what is exactly extensive properties? Which depends on quantity of matter present in the system. So mass is extensive property because every time if we take different masses, we can see that quantity of matter is less or more. Even work we can take in example. Okay, so mass and volume. So volume of any system what we have taken, if we take larger volume or lesser volume, it will depends on the quantity of matter, so it will change with quantity of matter. That is what extensive property. So second part is intensive property, which does not depends on quantity of matter. So intensive properties are those property which does not depend on quantity of matter present in the system. So the example of that, there are fixed or constant quantity which cannot change with quantity of matter. So if we take example of that is boiling point, BP, that is boiling point, melting point. It is not BP blood pressure, it is a boiling point. Okay, MP means melting point. Then also we can take example density, because it is a ratio of mass by volume. Mass and volume, sometimes students confuse, that is mass and volume are extensive property, but ratio of to extensive property, it is an intensive property. Okay, so viscosity, EMF, and there are also a lot of example of that one. All concentration terms we can take, that is molality. So concentration terms also ratio of mole per unit volume or mole per unit weight of solvent in kg. So ratio of to extensive property is always an intensive property. So in that example you can observe that, so if we have small quantity of water, if you have 1 liter water and one container we have 100 liter of water, 100 liter of water. So if we heat 1 liter water, their boiling point is fixed, that is 100 degrees Celsius. And if we consider 100 liter water, their boiling point is always 100 degrees Celsius. It means it does not depend upon if we take less water its boiling point is less, or if we take more water its boiling point is increased. There is no such cases like that. Sometimes a student may have confused if we have taking the large quantity or small quantity, they might be changed. No. So density of water is also fixed. It is not changed with time or with quantity actually, because it is a ratio of mass per unit volume. And we observe that density of water is fixed. There are a lot of substances which have fixed density value. Even EMF, that is electromotive force, melting point, viscosity. Viscosity means resistance to flow in any liquid, that is viscosity. So these are all the properties which does not depend on quantity of matter. If you are taken in large quantity any matter or in small quantity, these values are constant and fixed. But in extensive property we observe that if we take 1 kg of stone and we have to lift that one, we feel not too much heavy. But instead of that, if we take 10 kg of stone to lift, we will feel that weight, because it is depend on the quantity of matter. Volume is also depend on quantity of matter. If you are taking small volume or larger volume, it will depend. Internal energy or all energy terms. So energy means capacity to do work. So this is also depend on quantity of matter. If you have lot much work to do, so internal energy needed is too much. So that's why we will say that internal energy is extensive property. Okay. There is two important terms we will discuss. One is state function, and one is path function. So the name itself suggests path function, which depends on path taken to complete any observation or any part, and state function depends on initial and final state of system. Initial and final state of system, it will depend on initial and final state. Okay. So if we take example of path function, only 3 example in that one, that is work, heat and heat capacity. So how much work you have to done? See, if I am giving you some day-to-day life example of path function. So basically you have to do some work, means you have to keep one tiffin and give it to 5th floor. So you have 2 options. You have go to 5th floor by steps, and other option is you have to go by lift. So if you take the path to go the distance by lift, so it will be easy. It will not take too much effort for us. But if we take the path of steps, we might have feel that work. So it is depend on the path taken, or heat and heat capacity. These 3 examples of path function. And state function, it has to do with initial and final step. So as a teacher, if you see the students in classroom, we see that if they are now present in the class, that is their final state, and they are coming from their home, that is their initial state. In that between, from their home to their school, in between the path, they have taken different paths to reach that path. That is what not depend on the things. So depends on initial and final state of system, that is internal energy, enthalpy. Any other example we can take in that one other than that? Work, heat and heat capacity. Internal energy basically depend on measurement of heat at constant volume, and enthalpy is measurement of heat of any thermodynamic property or any reaction at constant pressure. If you measure heat at constant pressure, it is enthalpy, and if you measure heat at constant volume, it is a internal energy. So these are some basic terms which we are discussing in that lecture. So in next upcoming lecture we will discuss further part of thermodynamics. Okay, till that we will stop here. Okay, thank you, bye.